Welcome to the deep dive. This time we're diving into a world you might not think is very thrilling, integer sequences.
More intriguing than they sound, definitely.
I'm ready, though. Tell me more. We're looking specifically at A00007 from, it's called the Online Encyclopedia of Integer Sequences.
The OEIS.
Right, OEIS, much easier. Sounds a little bit like a database for, like, secret codes or something.
Not so secret, but yeah, there's some unpacking to be done there with A0000007.
Okay, so let's unpack it. What is this sequence?
Well, at its heart, it's called a characteristic function of this set containing only the number 0.
Okay, I might need you to break that down a little further for me and everyone listening.
Okay, so imagine a light switch.
Okay.
It's on or off, right?
Right.
A00007 is similar. The first number in the sequence is a 1, representing on, and every single number after that is a 0 for off.
So it's 1, 0, 0, 0, and so on forever.
Yeah.
That seems pretty straightforward. What makes that so remarkable? Why is this particular sequence of 1s and 0s in this OEIS database?
Because, and this is where it gets really cool, this deceptively simple sequence, it pops up in some really unexpected corners of mathematics, and it reveals these like really fascinating connections.
Give me an example. Where would we find it unexpectedly?
Well, let's take Pascal's triangle.
Okay.
Remember that? That triangle of numbers from school,
Vaguely.
where each number is the sum of the two numbers above it.
It's all about combinations, right?
Exactly. Yeah, it's incredibly useful for calculating combinations, probabilities, all sorts of things. And if we look at each row of Pascal's triangle and we calculate what's called the alternating sum, a curious pattern emerges.
Alternating sum, is that where you add every other number and subtract the other one?
Exactly. You add the first number, subtract the second, add the third, and so on. And when you do this with each row of Pascal's triangle, guess what?
Don't tell me it's going to be 1, 0, 0, 0.
You got it.
No way.
No way.
That's wild. Okay, so this really simple sequence is like hiding in plain sight in Pascal's triangle.
It is.
What does that even mean?
Well, it points to a deeper connection there between these concepts, right? Pascal's triangle, it's all about combinations, right?
Mm-hmm.
Ways of choosing things from a set.
Right.
And this alternating sum kind of trickery, it suggests that there's this hidden link between those combinations and the simple act of turning a switch on or off, which is what our sequence represents.
That's pretty mind-blowing when you put it like that.
It is.
It's like math is conspiring to like make sense of the universe in ways we never even thought of.
It really is. And the conspiracy deepens, let's put it that way.
Okay, tell me more.
A00007 also appears in something called Dirichlet multiplication.
Dirichlet multiplication. That sounds like a whole other can of worms.
It is a whole other can of worms, but we can unpack it.
Okay.
Essentially, it's a way of multiplying arithmetic functions. So these are functions that deal with whole numbers and their properties.
Right.
And in this world of Dirichlet multiplication, A00007 acts as what's called the identity element.
The identity element.
Yes. Much like, how the number 1 acts as the identity element in regular multiplication.
Okay, so it's like the 1.
Exactly. You multiply anything by 1, you get the same thing back.
Right, right.
So in Dirichlet multiplication, our little sequence of 1, 0, 0, 0, that's like the mathematical equivalent, it holds its ground.
Okay.
Keeps everything consistent.
I like it. It's like the rock, the steady one in this crazy world.
Exactly. And that's just a glimpse into the influence of this really unassuming sequence.
This is already more exciting than I expected from a sequence that's mostly zeros. What else?
Now, there's more. We're just getting started.
Okay, more. What else? What else is there?
All right. This might seem like a bit of a curveball.
Okay.
But let's talk about 0 to the power of 0.
0 to the power of 0. That's ringing a bell from some math class somewhere way back when. I don't quite remember the specifics.
It's a concept that gives even, seasoned mathematicians pause. Oh, yeah, because at first glance, you might think, well, any number to the power of 0 is 1, right?
Right. Isn't that like one of the rules?
Yeah. It's a pretty standard rule in the world of exponents.
Okay.
But it gets a little fuzzy when we're dealing with 0.
So is the big question, does 0 to the power 0 follow that rule? Or is 0 special?
You hit the nail on the head. That is the question. And this is where the debate comes in, because there are compelling arguments on both sides.
Okay, lay it on me. What are the arguments?
So some mathematicians, they believe that for the sake of consistency, 0 to the power of 0 should equal 1.
Okay.
Just like any other number, keep things nice and clean.
Yeah, consistency. I can see that. That's important in math.
Absolutely. But then on the other hand, you have folks who argue that 0 has this unique nature. You can't just ignore it.
Right.
And they say that 0 raised to any power, even 0, should still just be 0.
Okay, so it's like a math showdown. We've got team consistency versus team zero's specialness.
Exactly.
Where does A00007 fall in all of this?
Well, remember how we can define A00000 as 0 to the power of n, where n starts at 0 and increases?
Right, so the first term is 1, not 0.
Exactly. So this definition, it implies that the very first term, 0 to the power of 0, equals 1.
So it's almost like it's taking a side in this debate.
It is, and it just shows you how interconnected all of these concepts are.
That's so cool.
It really is. Even this simple sequence, it becomes a launch pad to explore these really fundamental questions about mathematics.
Yeah, it's like we just stumbled on this hidden doorway to a whole other dimension of math with this sequence of ones and zeros.
Exactly, and it kind of emphasizes that math isn't just this rigid set of rules,
Right.
It's really this living, breathing field of exploration and debate.
I love that. Okay, so we're talking about all these big theoretical implications of this sequence.
Yeah.
But for people listening who are thinking so what? How does this affect my life? How does understanding the sequence and even just having this debate about 0 to the power of 0, how does that change how we see the world?
That's a great question.
How does this affect my life? How does understanding the sequence and even just having this debate about 0 to the power of 0, how does that change how we see the world?
It's a great question.
Yeah.
I think it really highlights that even in a world that's so obsessed with complexity,
Right.
there's still this profound beauty in simplicity.
Yeah.
This sequence, it's mostly zeros,
Right.
but it opens up this whole universe of mathematical concepts, and it challenges us to question our assumptions about things we think we know.
Yeah, no, I'm really starting to appreciate the elegance of it. It's like a whisper
Yeah.
that leads to this roar of insight.
It really does, and I think it just underscores how interconnected everything is.
Yeah.
Even in this abstract realm of mathematics, who would have thought that this sequence of ones and zeros could lead us to Pascal's triangle, Dirichlet multiplication, this whole debate about the nature of 0.
It's like a secret decoder ring.
It is.
The universe.
It encourages us to look for these connections, to find these patterns in unexpected places.
Right.
And really, I think that's how real understanding happens.
Yeah.
By embracing curiosity and digging beneath the surface of things.
I love that. So as we kind of wrap up our deep dive here into the surprisingly profound world of A00000,
Yeah.
what's your final thought? What do you want to leave people with?
I would say, the next time you encounter something that seems simple
Okay.
or even mundane,
Yeah.
remember 0000007. Take a moment, consider what hidden depths might be there beneath the surface, because you never know what you might find.
I love that. A call to action, embrace that curiosity, and never underestimate the power of a good deep dive. Well, thank you so much for joining me on this fascinating journey. This has been great.
My pleasure. Thanks for having me.
And to everyone listening, thanks for joining us on the deep dive, and we'll catch you next time.